CYP2D6 is particularly difficult to genotype due to extensive sequence and structural variation. For my project, we're interested in assessing how much of the variability in CYP2D6 activity is explained by single nucleotide variants in indels alone, and if the inclusion of structural variation data improved the association. We use pgRNQ targeted exome sequencing data to assign diplotypes and associated activity scores to 309 human liver samples. Diplotypes were first assigned manually based on single nucleotide variants in indels alone, and then corrected based on structural variation data from Stargazer, a novel bioinformatics tool. We also perform human liver microsome incubations to assess metabolite formation rates of two CYP2D6 probe substrates, dextromethorphan and metoprolol. Diplotypes for 66 out of 309 total samples were incorrectly assigned, representing over 20% of the total, and 25 samples, or about 8%, were assigned an incorrect activity score. If the goal is to be doing precision medicine, incorrect phenotype predictions for 8% of patients isn't good enough. We wanted to know if these changes in activity score resulted in improved predictions of CYP2D6 metabolism. To do this, we looked at the linear relationship between activity score and dextromethorphan metabolite formation rate when activity scores are based on single nucleotide variation in indels only, and when structural variation data was included. We observed an increase in R-squared from 0.36 to 0.41. Put another way, this means that activity score explained 5% more of the variation in CYP2D6 activity when structural variation data was included. Data for metoprolol were similar. In conclusion, single nucleotide variation in indel analysis alone is not sufficient for accurate CYP2D6 diplotype assignment. Inclusion of structural variation data is critical for increasing the precision of CYP2D6 pharmacogenetic tests.